Hello, just when you've probably got used to 3D being a big visual selling point in the film world, for example, I'm going to ask you to think for a moment about 2D and the huge potential of a material so thin that you can barely see it. It's called graphene, and it's essentially a flat but flexible sheet of carbon. It could soon be used in products we all use. So here's our science editor, David Shukman, to explain a global race for graphene.
The glittering prospect of a strange new substance that could lead to a new industrial revolution. The tiny black specks on this tape are the extraordinary material known as graphene. Manchester University in Britain has pioneered graphene, earning 2 of the scientists here Nobel Prizes.
It's like early days of discovery of atom or something like that. It's really so surprisingly rich, and this is because we get this new world of materials which we were not aware before.
To understand graphene, you need to see the world through new eyes. Not the normal 3 dimensions we're used to, height, width and length. Imagine instead just one layer of atoms with only 2 dimensions. That's graphene. Graphene is so minute you need a microscope like this one of the most powerful in the world to get a sight of it. Here it is, a single layer of atoms, the thinnest material ever created, so thin it's basically only got 2 dimensions. Now let's use virtual reality to get a closer look at this stuff, because it's got extraordinary properties. If you stretch graphene, it turns out to be stronger than steel or even diamond down at the same scale, useful for making all kinds of things more robust. It conducts electricity far more effectively than copper, vital for future electronics. It's also amazingly flexible. You can bend it any way you want. You could have a computer screen that you could fold up like paper. No wonder people are talking of graphene as a material that could revolutionize the way we make things. This promotional video from Samsung shows one view of the kind of gadgets that could emerge with graphene. Paper thin, flexible, 3D. But it could also be used for new batteries or medical devices. That's why there's a global race to exploit graphene. Singapore, with this huge laboratory, is part of a surge of interest. The scale of worldwide investment is massive.
It's extremely competitive. Asia, especially Singapore, started early. Still, we have to see what's going to happen. There are lots of things going on, so it's going to take a little bit of time to find out who's going to win the race.
A key measure of who's winning that race is revealed by the patents filed for different aspects of graphene. China has more than 2,000. Samsung has more than 400, the most of any company. And Britain, which led the field nearly a decade ago, has just 42.
I think there's incredible interest around the world. And from 2007 onwards, we see a massive spike in patent filings in countries all over the world, particularly in the USA, Asia and Europe.
They're almost too small to see, but these tiny fragments of graphene are at the heart of one of the biggest scientific contests of recent times, with a great deal at stake. David Shukman, BBC News in Manchester.
So hopefully you now have an idea of why graphene has such huge potential. With me now is Dr. Aravind Vijayaraghavan from the University of Manchester. As David explained, that is the university at the forefront of research in this area. And Dr. Aravind's come in armed with a few bits of graphene.
Yes.
Tell me what you have there. I'm particularly interested in the liquid. What's that about?
Well, so what we have here essentially is, you could think of it as graphene ink,
yeah,
or graphene solution, which it's got flakes of graphene in a solvent. Now you could use this, for example, for printing electronics like printable ink. You could use this as the starting point for making composite materials that could be strong and conducting. You could use this for coating surfaces if you want to make a conductive coating. You could use it for that.
And it's a combination, isn't it, of the thinness and also the strength, which is so striking. Because something else you brought in is the I mean, wafer thin, really, graphene.
Well, it's sort of even thinner than wafer. It's like graphene paper. It's very thin. It's very light. If you blow,
like
it just sort of blows away. Almost similar to that. But this is essentially graphene filter. Absolutely. It's very light. It's very...
It's going to fly away here in our studio.
Pretty much, yeah. You could use that, for example, for filters.
Yes.
Things like desalination. So you could use, or molecular separation. So we would make something like that with graphene for use in filter applications.
Okay. Well, let's talk about the applications then, because I think we've also got some moving pictures that give us an idea. I mean, this is not something which is really used in consumer products at the moment.
Not yet, no. We don't have
But
any...
it could end up in something like this.
Well, yes, flexible technology, flexible electronics is one of the things that we are really excited about in graphene research, because graphene has got a combination of properties that's quite unique. As you can see, it's conductive, it's transparent, it's strong, it's bendable, it's stretchable. So any sort of flexible electronics or wearable electronics, you would need all of these properties to come together.
Wearable electronics?
Wearable, things that you could basically wear on your skin.
I could sort of have my mobile phone or even my computer screen maybe one day on my wrist.
Or electronics that's integrated with your clothing, something that needs to move, bend, stretch, flex.
I mean, how far into the distance are we talking with things like that?
Well, flexible electronics, for example, you're looking at 10 years down the line. But graphene, for example, in touchscreen technology, which is there today, so where you're replacing something that's there today with graphene would be a few years down the line.
So the roll-up computer screen, for instance?
Well, the roll-up screens would probably be 5 to 10 years down the line, because that's something that doesn't exist today.
Yeah.
You're trying to make something brand new, so that's a bit farther down the line.
But is it your belief that one day we will probably all be using things that have elements of graphene
absolutely,
in them?
absolutely. That's why there's so much of excitement, there's so much of investment, there's so much research that's going into graphene, because it's got a real possibility that one day it's going to end up in things that we will use every day.
Okay. Lastly, I want to ask you if it's safe, and I speak as someone who is holding quite a lot of graphene in my hand, because I have heard that, you know, some researchers worry about breathing in the tiny particles that are in graphene.
Well, I mean, it carries with it the exact same risk that any nanoparticle would. But nanoparticles are there in everything that we use every day. Everything from cosmetics, makeup has nanoparticles in it. So nanoparticles inherently are not dangerous. It's just if you handle them wrongly, if you take them into your system in the wrong way.
Okay. Am I handling this correctly?
That's fine.
Okay, great. Well, it's good to know. Worth checking while I have the expert here in the studio. Thank you very much, and thanks for coming in. And there you go, graphene, something to look out for in the future. That's Dr. Aravind Vijayaraghun from the University of Manchester. You're watching Impact from the BBC. Coming up, we've got a face-off between Lagos and Paris. It's the next stage of our gridlocked world challenge.